Hello and welcome to this session on Hive. So Hive is basically a data warehouse tool which is used to analyze the structured data. It can also help in semi-structured data as well. It is something which was built by Facebook. It is now open source. It is free. You can download and install it. Now, if you look at the Hadoop 1.0 architecture that we have discussed early in the course, and now we mentioned that the programs were developed using something called as a MapReduce, the Hadoop program. So MapReduce was built on Java. So if you know Java, then you can leverage MapReduce. But then if you don't know Java or if you didn't know Java, then there was no scope of leveraging the big data technology. So that's the reason why many firms came forward, many projects came forward to build different tools that they can use to leverage the data, big data, right? So one of them was Hive, the other is Spark, which we will learn in the coming session, but there are quite a lot of tools. So how Hive works is basically you have the data in the HDFS and then you create a table. You create a Hive table. This is very similar to your normal relational database table. Now this table will refer to the data in the HDFS location. So when you query this table internally, this is going to go to this file system and it is going to pick up the selected data from this file system and it is going to print it on the screen or give it back to you. So it is very easy to use. If you know SQL, this is damn easy. Most of the SQL queries we can use it in a Hive as well. There are certain changes, but they are very small changes, but yes. So Hive stores its metadata in Hive Metastore. The Hive Metastore is basically a relational database. It shows the metadata related to the tables, the schemas that you create. You know, all these things are stored in the Metastore. So when you create a new Hive table, the information related to that table, meaning the column names, the data types, the table names, everything is stored in the Hive Metastore. Hive by default Hive uses Derby database for its meta storage. Now, if you look at the features of Hive, it is open source, right? As we mentioned, it is an open source which was developed by Facebook. It is very similar to your SQL. The Hive query language is very similar to your SQL. So, if as we progress throughout the course, you will see that most of the syntax or the select queries that we use are very similar to your SQL. Hive is schema on read. What it means is if you have a structure and you're trying to insert the data into this structure, now in normal traditional databases, your data should match with your structure, right? Suppose you have 4 columns that you created in a table, and if you're trying to insert a record which has 3 columns or 5 columns, then it will throw up an error, right? Because it's not matching. But here in Hive, it will allow you to insert this data because it is not going to do any checks while it's trying to insert the data. But when it reads the data, when you query the data, it will go to the meta store, it will fetch the information and it will validate the data. That's where you will see this issue. So Hive will enforce the schema while it is reading or retrieving the data from the HDFS. It can be used an ETL tool. You can have transformations. I know a lot of projects which use Hive as an ETL and it can process huge amount of data. It has the concept of partitioning and bucketing. So we will learn this in a separate session. It's a data warehouse tool as we have mentioned earlier. It is basically used for analytical purpose. So in fact, most of the big data, in fact, all of the big data tools we use for analytical purpose because we want to process a large amount of data. This is not for transactional purpose, so there will be limits on how we do the DMS. Mostly I have never seen a scenario where we have to do any DML operation, and it's not the case as well. It's not the case that we use DML. Most of the projects, in fact all of the projects, they are basically using for ETL purpose or for doing analytical purpose, definitely not for OLTP. There are different file formats that we can work on. We have seen the serialized file formats like ORC, Parquet, Avro. So all these file formats can be used in Hive now. And then there are also projects where you have the BI tools. They plug into your Hive, you retrieve the data from Hive, and then publish the data on the data visualization tool, right? So it has compatibility with the BI tools as well. You can connect your BI tools with Hive and get all this data from Hive. So these are some of the features of Hive. And coming to the limitations, so it's not basically a limitation, but it's kind of a feature that, it's not for your OLTP, right? It is basically for your OLAP. Now subqueries, you can create subqueries, but it has very limited support for subqueries, because as I mentioned, it is more of an analytical thing. So your aggregations or your simple select, that's where your Hive queries are used predominantly, but not for having a lot of subqueries. Latency is a little bit of on the higher side. So you will see that when you do a query, it will, because internally it has to invoke the MapReduce job, and then it has to go and fetch the meta store, get the data, all the stuff. So your latency, you will see, is a little bit on the higher side. Not really that big, but yes, it's something that you have to keep in mind while using Hive. And DML operations support is there, but then you have to satisfy a lot of conditions to make sure that you are able to do the DML operations. Most project, again, this is something we don't use it for Hive. This is basically for OLAP, not for your DML operations. And not for real-time queries. The reason is basically your second point or third point, where we said like there is some latency. So if you want the data on real-time basis, Hive may not be the right candidate for you, because it will take its time to give back the results. But then yes, these are some of the limitations of Hive. So that's the theory part of this. And in the coming sessions, we will start hands-on, and we will create the tables and see how Hive is working with the data. So I hope this is clear, and I'll see you guys in my next class. Hello and welcome to this session. So we'll jump straight up into the practical session. So I'm going to open another session here. I'll duplicate this session. Now I'll enter into the Hive shell. So to enter into the Hive shell, you simply type Hive and enter, and then it will enter into your Hive shell. So all right, so we are in the Hive shell. So first thing that we want to do is we want to create a database. So let's say we want to create a database called as practice. Again, this is very similar to your normal database. Create database name. We will create practice database. So we have the practice database. Now to use this practice database, we use practice. Again, same thing that we have done in the MySQL as well. No difference, right? Now what happens is whenever any database or any new table is created, by default Hive is going to create a directory, and the default location is user Hive warehouse. So if I go to this location, I should see two folders. I should see a folder getting created. So you can see this, right? So this is the folder that got created, practice.tp. So every time a table is getting created or table gets created, you will have a folder getting created under this default location. In the coming sessions, we will see how we can use some other external location, but this is the default location that the Hive uses to create the folder. So now that we have created the database, the next thing that we want to do is we want to create a table. Okay, let's do something. Let's create a customer table. So what we will do is this is my MySQL, and I'm going to create this customers table. So if I do a describe, so I have, these are the fields that I have. So I'm going to create a Hive table with the same structure as I have in the customers. So it's quite simple. It's very similar to how you create your normal relational database table. So you give the create table name, and you give the table name here. Then you mention the column names here. So I'll just copy these columns from here, if you can see that almost most all of them are very same. I'm just copying this everything from the MySQL database here. All right. So this is normally how you create a table in your relational database, right? Now, this is where it is a little bit different in Hive. So the table is now, you can create this table, but then underlying data is basically present in your file system, right? So now you have to mention how is that file, what is the delimiter of that file, and what is the type of the file, what is format of the file. So the first thing that we will do is we will say row format delimited, because the file that we have copied on the customers, it's a row delimited file. And how are the fields terminated? We have to mention this here, fields terminated by, we have copied a CSV format, so we have to mention fields terminated by. And again, the next is lines. How are these lines terminated by? This is /n, the new line. And stored as, how is your file stored as? So we are talking about the customer's file that we exported from the MySQL, we copied into the edge node, from there we put it in the HDFS location. So if you remember that it was a comma delimited file with /n as the new line director, and then we stored this as a text file. We have seen those files, right? So this is how you create a table. So if I enter, now my table is created. So I will go back here, and if I do an HDFS on the Hive user warehouse, you should also see one more folder being created. It should be under this. Let me do this. So under practice database, you should see this table. Yep, the customers. So this is how it maintains the metadata and other information. So this is the default location of the Hive. So okay, let me go back. Okay, now let me go back to the Hive. Right, so here we are. So if I do a show tables, it will show me the list of tables. So we only have customer tables here, right? So again, same thing that we will do in MySQLs. Now if I go and describe this table, describe my table, which is customers, it should give me the schema of this. So it has all the column names and then the data type. But there is something else we can do. So if we can do something like describe formatted and then the table name, it will give me a little bit more details, like these are the column names that it has. It gives the owner name, other stuff, the location. So as I mentioned, this is the default location. Now all the data that we are going to put into this table is going to get loaded here in this default location. The table type, it says managed table. Basically there are two types of table, one is managed, one is external table. By default, if you don't specify anything, it is a managed table. We'll talk about the difference between managed and external in some other video. But then if you look at this, there are the SRD libraries, how the data is getting stored, your format and other stuff, and number of buckets and something that we will see at some other point, right? So anyway, so this is describe formatted. So it is very useful, and this is something that we are going to use very regularly. For the most important here is basically location. So this is something very important. So whenever you do a describe, the first thing that you should do is check where the data is getting stored, right? So this way you can go back and check this data in the location that is specified here. All right, fine. Now what we will do is we are going to load the data into this table. Okay, so where is this data? It is basically in the you have the data in both HDFS location as well as H node, but we will check this data in our edge node first. So under data sets, we have this data, so which is basically we have the customers, we have categories and other stuff. So we created the customers file. So what we will do is we will load this data, customers file into this table. So one of the way that we can do is using a command called load data. So we will say load data. This is the command. We wanted to use local system, so we says local, and then we give in path. So this is a path where the file is present. So it is under home Cloudera datasets, and we have to give the full path. This is the customers.csv. So this is a file into where, which table we wanted to insert. So our table name is customers. Okay, so load data local in path. This specifies that we want to load the data, but the data is in local. This is a location where my data is there, and this is the table that I want to insert my data. So if I press enter, this data is getting loaded, and it has already got loaded. All right, so if I do a simple select, I'll see all this data. So let me do a limit on this. Again, same set of queries that we use on your MySQL. You can also do a where clause. Let me do a simple where clause. I think this is customer ID, right? So let me check for customer ID is equal to 1. Okay, is it not customer ID? We can describe it. All right, so we have the customer ID details here. Okay, we missed the where clause here, that's the reason. Anyway, so simple queries that we can do, there are other group by queries as well. All of them will work. So let me describe this table again. Now if you look at this, I can do a simple group by as well on this. So let me say I want to do a group by on state. I want to see how many records we have for a particular state. So I'll say count of star. And it will invoke your MapReduce job, and because it's a group by, it is going to take some time. So we have this result here. So very similar to how your normal SQL query. So if you know SQL, it's very easy to learn Hive. You just create the table and you do your normal SQL queries, and most of the time it is going to work. Okay, so what I'll do now, I'll do a describe formatted again. And I'll go to this location. So this is the location where my data is getting stored. Okay, so I'll have to go here. Let me go here. All right, so you can see here that data is getting that data got loaded here. So if I do a cat, so from this is where the data is getting loaded into this table. When we do a select query, this is where the Hive query is picking this data, right? So this is how we load the data. So we have loaded the data from your local system or your edge node into your Hadoop table or into your Hive table, right? So we can also do the same from your HDFS location as well. So what I will do is let me just open here. So this is a command we use to load the data from edge nodes. So now if we want to load the data from your HDFS location. The first thing that we have to do is we have to remove this local. Now this means the data is getting, this means that the data will be loaded from your HDFS location. But your HDFS location, we have to change your HDFS location. It is basically user Cloudera, right, into this table. This is where your data is present. We copied the data here. Let me quickly check that to see if there are any spelling mistakes. So I'll do a simple ls command to see if the file exists there, right? That will be an easier way to identify if there are any spell mistake. Okay, it looks like there is some spell mistakes. I think we created the directory as well, right? So great. So this should work. Yeah, so we created the directory and we loaded the in each of this directory. Yeah, so here I have to mention customers and into this custom, right? So if I execute this, it is getting loaded. It has already loaded the data from the HDFS location into the customers table. Okay, so if I do a select star, or let me do a describe, or rather so we have this location anyways here. So let me just go and check this if any new file has been added. It should get added. You should see two files here. One was this was a file that we loaded basically from your local, and this was a file which we loaded from your HDFS location. There is some difference when you load the data from your local system and when you load the data from your HDFS location. So what happens from your local system is when you load the data from your H node, data is basically copied to your Hive warehouse location. But when you load the data from your HDFS, data is actually moved. So the original location, original data is actually lost in HDFS. So we can verify this. So this was the location. This was the location of the HDFS. So if I do an HDFS here, I will not see this data because this data was moved. It was not copied, rather it was moved, right? There is no such data. But if I do an LSLTR, you will see that this data is still there in the local system. So that's a basic difference. When you use a load command, the data, if you're using the in path as local, it will copy this data from your local system, which is edge node, to your warehouse location, higher warehouse location. But if you're using the in path for HDFS location, it is going to move the data. So that's the basic difference between loading the data from your HDFS location to loading your data from your local system, right? So what we will do is let us just copy this data there. If you want to copy from local, so we say copy from local. So this is the file that I wanted to copy, and I want to copy it here. This is where I want to copy it. All right, so we have copied this data from local system into the HDFS. Let me just verify this one more time to see if the data is available. All right, so we have this data. So that's the basic difference. Please do remember, if you're copying this data, if you're loading the data from your edge node, the data is basically copied. But if you're copying if you are using an inload to load the data from your HDFS location, data will be moved. It's a very important difference that you need to understand, right? Okay, so moving ahead. Now we have mentioned that when you load the data in the table, basically it means the data is loaded in some HDFS location. In this case, the data is basically loaded here. The customer data is basically loaded here. So let me go here, and when you query the table, when you query the Hive table, data is basically copied from, data is basically loaded from here. So let me just quickly go back and do a query on Hive. I'll do a simple select count of star. All right, so we have 24,878 records. Now this is what we have here. So what I will do is I'm going to delete this particular file. When you delete this particular file, that data is not available, so it should reflect in your Hive query as well. So I'll do this. I will do an remove command and this data will get deleted here. So the data is deleted. Now I'll go back to my Hive and I'm going to do another count of stars. So earlier we had 24,878, so we deleted one file. Basically it's the same file, so you should ideally be seeing the half of it, which is some 12,400 something. There you go, it's 12,439. That's half of it. Now what I'll do is I'll go back and I'll delete the remaining file. So when you have when you remove the other file as well, so when you query this data, that it has nothing in the HDFS location, so it should return you 0 records. So we deleted this data. So now instead of using a count of star, I'll simply use select star from customer. So this will be rather easy. So we got no records here. So basically this is how the Hive works. So you have the data stored in the HDFS location, and then Hive is going to pick up this data from that location and it is going to show it up to you on screen, right? So this is the basic concept of Hive. When we looked at the features of Hive, we saw something like schema on read. So there we mentioned that you, even though if you have a mismatch between your file system within your data and your Hive table, it will still allow the data to be inserted. So let's test that. What I'm going to do is I'm going to create a simple table, and I'm going to have just one column in this. So I will call this table as order underscore example. Let's call it this way, and I will only create one column in this. It's a row formatted delimited. Basically the orders, we are basically referring to the orders file that we have loaded. Fields are basically terminated by comma, lines are terminated by slash n new line. This is stored as test file. All right, this is great. Okay, the table is now created. If you do a describe formatted, so the table is basically created here. So you can see here a new folder got created under practice.db. So this is great. Now what we will do is we are going to load some data, and the data that we want to load is if this is the location, so this is the data that we want to load, orders data. Now if you do a head on this orders, you see this is one column, this is second column, third and fourth. So we have 4 columns, but then the table we created basically has just one column. So you're trying to insert the data into a table, but you have 4 columns while the table can only accept one column. Normally if you do in a relational database like Oracle or MySQL, it will fill right there, right? But here this is where the difference is. If I do this, let me load data local, because it is in my local edge node, and here is the location of this file, and the file name is orders.csv, and into table the table name is order underscore example. So this is a table that so it has loaded. So if you can see here, right, the data is loaded. Now if you go to this location, this is where the data is getting stored. So if you go to this location, you will see that file present here. So data is present, right? So you have this data. So if you cat this data, you will see the same data that we have loaded, right? Yeah, so it has all the 4 columns. This is great. So the data is available, but if you do a query, if you select this query, you can see here, right, it has only picked up one column data. There is no failure here, right, because you have four columns data, but your because your table has just one columns, it just picked up one column, it just picked up the first column data. In your traditional skill, this could be a failure. So your schema is basically applied when you are reading this data, even though it allowed you to load four columns data, but then when you're reading the data, your schema says just one column. That's why you are seeing just one column of data, right? So this is what we meant, what we are mentioning about the schema on read. Now let me do another describe. Okay, so you see here the table type is managed table. So what is managed table is basically the difference between managed and external is, in managed table, if you drop a table, it is going to drop the schema, as well as it is also going to drop the data associated with this. Now if you see here, the data is present right here, right? We have just verified the data is present, but if you drop this table, this data is also getting dropped. That is what managed table is. An external table, as we will see in the coming sessions, that's not the case, but let's limit ourselves to a managed table. So I will say drop table. Okay, so my table is dropped. So if you do a select star from this table, or you do a describe, you should see something like this: table is not found. So similarly, if I go and check if the data is present here, if the file is present here, I should see a similar error here, that the file or a folder or directory is not present. So this is what happens in a managed table. So you have to be very careful when you create a table, because your underlying files may also be lost if you're dropping and recreating a table. So this is a very common scenario in your relational database. Sometimes a new schema comes up, so you want to drop the existing table, copy this data somewhere else, create a new table. So you can do the same thing here with managed table, but there is a better way of doing that. But anyways, when you drop the table, the underlying data will be dropped. That's the concept that I wanted you to understand right now. Okay, let's do one more thing. Let's create one more table. So I'm going to use a create table. I'll create the categories table. So this is the same table that we have in the MySQL. So if you describe the categories, you'll see like there are three columns. So I'll quickly create those three columns. This has been an easier way for me to just copy it and paste it. Right. So we have all those three columns. Now what we have to do is we have to mention the row format. So row format is delimited. Fields are terminated by it's a CSV file, it's terminated by comma, and lines terminated by slash n, the new line character. And this is stored as text file. This is how we have created the tables in our previous examples, right? What I will do is I'm going to use something called as location. So what it means is it just tells the Hive that, right, my table, this particular table data exists in this particular location. So whatever location that I give here, it should be an HDFS location. Table is going to retrieve the data from that location. So I'm going to use this user. So this is the location that I'm going to use, user Cloudera dataset categories. So you have to give up to directory name. So whatever the files are which are present under the directory, all those files will be pulled when you do a query. Okay, so this is something that we have copied in earlier sessions. So I'll give that location, right? So now what it means is I have a table called as categories. It has this is a schema of that category. It is a row format delimited, and fields are terminated by comma. It's a text file, and the location of this file is, this is the location, this is where my data is residing. So the table is now created. So if I do a describe formatted, you should see this. So you should see that the table location is updated. So the table location is basically this one, right? Okay, so now you can do a simple select query. So it's a table name categories. Okay, all right, so you have this table data. So this is another way where we can create this table. Now what happens if the location that you mentioned does not exist, right? You here we have already created this location, so we use this location. So but if the location does not exist, what will happen is it will create this location. So let's say you have up till here, so it's gonna create this categories folder, and then you will have to load this data into this. So you can use the load in path, and you can basically load this data into this location. Now you can also create a table with the existing table. So again, this is something that we used to create a lot, in your SQL. When you do an SQL, when you are writing your queries into traditional database, you would have come across a scenario where you want to create a table which has similar data types or similar structure as the existing table. So instead of doing a create table again, you would basically use create table as, and then you use a query. So if I use select star from categories, it is going to create it is going to create a table with the category structure, and it is going to copy the data from category, right? So the map reduce job is invoked now, and the table will be created, as well as the data from the categories will be copied into the category underscore example. All right, so we have the table created. So let me do a select count of star on this table first. So we have 58 records here. So what I'll do is we can also insert this data into this. So we can say insert into this table. And we will use select star again, select star from categories. So it is going to select the data from categories, and it is going to insert this data. So what will happen is you already have 58 records. It will again copy those 58 records from categories, so it's going to append to the existing table. So you should have 58 plus 58, that should be 160. Okay, so we have this data now. So let me quickly go ahead and write. So we are executing the select count, and this should be 58 plus 58. It should be 116 records that we should have. All right, so we have 116 records. So when you insert the data, it is basically appending it. So what if we just want to overwrite it, right? So instead of inserting or appending the data, we just want to overwrite it. So what we can do here is, so this is a command that we have used. So instead of insert into, we will say insert overwrite. So that's the only change. So when you do this, it is going to remove the existing data, it is going to fed it with the new data. So it is basically going to override. Now your 116 data should now become 58, because that is the data that is available in the categories table. So the command is now complete. So I'll execute the count of star again. This override, if it works properly, you should have 58 records. Anyways, let's wait for this command to get executed, and we'll verify this data on the category example table. See, we have just 58 records here. So let me do a describe formatted. We haven't done this for the new table, because this table was created from the original table, right? So this table is basically you have the same schema, everything, and you basically have the same database, but if you can see here, right, the location is your default location. The original table location was something else, right? You have user Cloudera, but when you create this table with another table, you didn't mention any location there when we created this table, right? So when you don't mention a location, it will take the default location. So the schema will be same as the original table, but then location will refer to the user Hive warehouse, which is the default location. Right, so we have done a lot of things here. So we have created a lot of tables, we have loaded this data, we have queried this data, we have done the group bys, we have done simple select, and we have seen how the data is moving from edge node to HDFS. What is the impact of loading from your local system or your edge node, or what is into the table, or what is the impact of loading the data from your HDFS location to your Hive tables, and how we can create the tables, different ways of creating the tables. So very simple, very similar to how we do the SQLs, but a slight difference where we provide some additional details. But I hope this was clear to you guys, and I'll see you guys in my next class. Hello and welcome to another session of Hive. So Hive, we have two types of tables. One is the managed table and the other is the external table. We talked about this a little bit earlier classes as well. So managed table is basically the tables that we have been creating until now. So what happens with managed table is when you drop the managed table, the backend directory, the backend files associated with that table is deleted as well. So we have seen this as well in the previous sections where we have dropped the managed table and then how it impacted the file system in the backend. So generally the managed tables are used for staging purpose, because if you have a staging table where you are basically using it to store temporary data, so that's where you use the managed tables. Otherwise we don't use the managed table. The other table which is predominantly used is called the external table. So what is the difference between managed and external is, in external table, when you drop this table, the table schema is deleted. However, the backend directory, the files associated with the table, the actual data would still exist. So this way, when there is a schema change, or instead of storing this data or copying the database somewhere else, you can basically drop this table and then your data will still exist in the backend. So these are the basic two tables. This is the difference between the two. A simple difference: in a managed table, you drop a table, your associated files will also be deleted. If you drop an external table, the schema is deleted but your data will still exist. So that's the basic difference. And how do we create an external table? So this is the table that we have created. This is a query that we have used for creating your managed table. So we have the table name, we have the columns, we have the row formatted others, and we have the location where we want to store this, where the data is available, right? Now if you want to create the external table, it's very simple. Here you just type external, that's it. It is that simple. There's no other difference. If you mention is external, the table that will be created will be an external table. If you don't mention external, the table that will be created is your managed table. So what I'll do is I'll go ahead and create this table. But before that, we'll have to drop the existing table, because this practice under dot customers is available. So the table is now deleted or dropped. So I'm going to go ahead and execute this. Okay, so the data or the table is now created. So if I do a describe formatted, so you can see here the location, which it points to the location that we have given, but the table type, if you see, it is now saying external table. It's not the managed table. So this is a location that this table is using. So if I go and check this location, I have to use it here. Okay, so this is the location. So let me do a quick ls on this location. So we have this data here in this location. So we have this data. So let me go ahead and quickly do a select star on this customers. Right, so we have this data. So what I'll do is I'll drop this table here. So I drop this table. If I query for this table, I should get an error saying this table is not existing. Yep, so this table does not exist, but what will happen to this data? So if I go back and query this data, and I should still see that file present here. So that's the basic difference between your external table. So it was, if it was a managed table, this data would have been deleted, but then since this is an external table, the data is still present. So this is the basic difference between your managed table and an external table. Again, use managed table if it is a staging table, use your external table if it is a target system. So that's it. I hope this was clear, and I'll see you guys in my next class. Hello and welcome to this session. So in this session we'll talk about partitions, what is the importance of partitions, and we'll do a lot of hands-on partitions. All right, so let's understand this with an example, the importance of partition. So assume that I have a file or I have a table and I call it as a country. So this is my table and it has some data. So basically I have three country codes where I have India, New Zealand and Australia. So these are the country code details like IND, NZ and AUS. So all right, now if I have to query on country code, let's say I'm looking for data belonging to country code IND. So I have to say select star from country where country code is called IND. Now imagine this country table has 1 million records or 10 million records. So if India records are maybe like if you have just 10 records, in order to get those 10 records, it has to scan all those 1 million or 10 million records, right? It has to go through all of these records, search if it is having the country code as India, then only it has to take it back, right? So this is how your normal query works. Now I'll take it a little further. Now what I'll do is, instead of storing this data in one single file, what I can do is I can basically create three different files. So I have file 1, file 2, file 3. Okay, so all the data that is belonging to the country code IND, so I'm gonna put it here. All the data that is belonging to the country code NZ, which is New Zealand, I'm gonna put it here. All the data that is belonging to Australia, I'm going to put it here. So what will happen here is, if you do a query like this, now this is your query, so your query is only going to hit this particular file instead of all the New Zealand and Australia file. So this way you are limiting the number of scans. You're basically taking only one file out of three, 1/3 of the scanning is done. So this way you are limiting the scan, total scan, table scan, and then this will improve the performance. So this is basically the concept of partitioning. You partition the data, you divide the data into smaller partitions, and then you save them, and then when you query it, it will only query those particular partitions. So that's the importance of your partitions. And this is the generic definition. Partition is a way of dividing the data into table into relatable parts using a partition column, right? So you have a partition column, you divide the data based on that partition column. Again, this data has to be related. You need to be very careful. You need to make sure that you pick up the right partition column. So because if you pick up a column where you're not gonna do any query on it, then there's no point of partitioning on that column. So pick a column which you are sure that you're going to query on it regularly. All right, so there are two types of partition. One is static, one is dynamic, and as the name suggests, static partitions are something which is created whenever a user specifies. Dynamic partitions are created dynamically. All right, and in the static partition, there are again two ways how you can do a static partition. One is using a static load partition, other is static insert partition. So in static load, we specify the partition name to which the data needs to be loaded, and in static insert, what we do is first we create a non-partition table, which is a normal table, and then we insert the data from this non-partition table into a partition table. So you need to create two tables. One is your partition table, other is your non-partition table. You insert the data into the non-partition table. From there, you insert the data into your partition table. Again, we'll see an example of all of this that will make things a lot easier. So this, what I will do is I'll jump ahead right to the code and we'll start coding, right? All right, so I'm at the Cloudera. I have my Cloudera open. So what I'm going to do is I'm going to go to a folder called as country. So I have created a folder here. If I do an ls ltr, I have files. I have India, I have America, I have countries files, right? So these are the same files that we have uploaded, we have put in the previous session. So we have already worked on this files. We have also worked on this files in the scope, right? So you can copy these files to this location using the WinRecipe, and I think we have already done that in our previous sessions. But if you have not yet done, so what you can do is you can create another directory by name country, or it's up to you where you want to place those files. Take those files from your local system and push them to this location. We just need those files here. So these are the same files that we have already worked, like the India file, or if you look at the American file, what we have is we have three columns where the first column is basically a state, then you have the capital city, and then you have the language which is spoken, and countries is basically the combination of these two, right? So we have the data from both in your America as well as your India. So that was your countries data. All right, so let me just clear this data for now. Okay, so we have these columns here, we have these tables, or we have the files here, right? So we have two files which is India and America, which the structure is basically same. One belongs to India, the other belongs to American data. So first what we will do is we'll create a Hive table and we will load these files into this table. All right, so I'm going to go ahead and create a Hive tables. For before that, what I have to do is I have to go into the Hive shell, right? So let me quickly do that. So you type Hive and it will take you to the Hive shell, and then you can start writing the Hive queries here. Okay, we are in the Hive. So we're going to create an external table. So we'll say create external table. Let me call this as normal table example. Okay, and the column names, we have state. So let's take this varchar up to 55 to be on the safer side. Then we have capital again. Let's take 255 varchar. Language, will keep it as 255 as well. So yeah, so these are the three columns that we have, and again these are row formatted delimited. All right, and fields are terminated by comma, right? If you go back, let me check any of the files. So if I do an India file, or let me just take ahead, you can see this they are terminated by a comma. All right, so those fields are terminated by your comma, and these are your text files. So we have to say stored at test files, and location, this is where you want your files to be saved, right? So we'll give the location Cloudera normal directory example. So this is in your Hadoop environment. So what we want to do is we want to store this, you want to take this data from your files and we want to insert it into this normal table example. So obviously this will get added to this particular folder, right? So let me go ahead and create this table. Okay, so we have the table created, so this is good. So this table is your normal table. We haven't done any partitions here, we haven't created any partitions. All right, so this is your normal table. Okay, so now let's load this data. So how do we load this data? So load data local in path. We are using the local file because we want to load this data which is present here, right? So this is the data that we wanna load into. Okay, let's go ahead. So this here, and I wanna load India data into table. So this is my table. All right, so I want to load it here. So this is complete, and I'm going to do the same thing for American file as well. So we have two files with the same structure. So we have created a table and we are loading the data into this table. All right, okay, so if I do an HDFS, so let me do this HDFS here. So let me clear this. Okay, so if I do an HDFS here, so you can see here, right, there are two files. One is an American file, one is your India file. So you have two files. So if you do a query, let's say what I'm going to do is I'm going to do a small query. So let's say select star from this table uh, where let's say language is equal to English, or let's say state is equal to Karnataka. All right, so it will give me the result here. But what is happening here is that if this query is basically going to hit both this files, so it's gonna search here, it is also going to search here. So it is doing basically full scan, it is scanning all the files. This is because what will happen is Hive is going to query on the directory. So these are files, right? So these are files. Hive is going to query the directory. So whatever is under this directory, it is going to scan all of them. Now this is where we're going to do a little tweak. So what if we divide this data into two directories? Not two files but two directories. So we'll create a directory for America, we'll create a directory for India. So Hive basically when you query it, it will query on the directory, right? So it has to either hit the India directory or it has to hit the America directory. So this way it is not going to scan the entire file system, it is only going to scan part of it. So basically we are reducing the scan by 50%. So this is something we can achieve using a partition. So we can partition this data. So we can create two partition, one is American partition, one is your India partition. And then what we can do is when we query this, it will either hit the American partition data or the Indian partition data. All right, so let's do that. So for that what I'll do is I'll create a table, I'll create an external table. So I'm gonna call this as what do we call, let's call this as partition table example. All right, and yes, so this is the same data. So the state is 255, we have capital of 255, basically the same structure, there's no change here. Okay, and here what I'm going to do is I'm going to say partitioned by, so I have to give a column, so I'll call it as country. So country is basically how you want to divide this data, right? So you have America, you have India, so that's how you want to divide this data. And this has to be row formatted, delimited. Your fields are terminated by your comma. These are stored as text file, and yeah, the location I want to use is let me use this as the location. All right, cool. Okay, so let me go ahead and execute it. So the table is now created. So I want to load this data into this table. So I'll say load data local in path. So load data local in path, and this is my file is under Cloudera country. So let me first add India file into table. So the table name is partition table example, and here you have to say partition So you have to create a partition. So I'm gonna say part country. So because that was your partition column, right? Country. So I'm gonna say India or IND. All right. So let me go ahead and execute it. So the data will be created, and now a partition by name IND will be created. So I'm gonna go ahead and execute this one more time, but this time I want it for America. All right. So I'm gonna say this is my American file, and yeah, and this country code should now be US. So let me execute this. Now what I'm going to do is I'm going to check this directory. So now you observe there is some change that happens. Okay, now if you go and observe this, so you will see two directories. So these are two directories here. They are not files, these are directories. So if you go ahead and any of this, and if you see here, right, let me go ahead and check for India. So you should see files here. Okay, so if I see a file India, similarly if I do a query on this folder, you should see a file on US. All right. Okay, so how does this matter, right? So let's say I do a simple select star. Okay, let me do a simple select star on this partition table. Okay, simple select star. So what happens with the simple select star is it is basically going to check this folder where this is let me go back. So this is the folder, right? So it will go and check this folder. So in this folder you have two folders. So under this folder, whatever is there, it is going to here's this folder. Under this folder, whatever is there, it is going to scan all of this. So in this case, it is scanning both Indian data and US data. So it is basically a full scan. But if I do something like this, let me say where country equal to IND. So what will happen is here, instead of scanning the end, so here what will happen is instead of scanning the entire folder, it is basically going to scan where country equal to IND. So see this country equal to IND. So it is only scanning this particular folder. It is not scanning this folder. So this is how you are reducing the scan. So 50% of the scan is reduced. Now only one folder it is going to scan, a subfolder of the main folder. So that's how you are going to save time in your query. So this is cool. So this is the importance of your partition. So what we did here is let me go back and let's recap one more time. So what we did is we created a partition table. So the partition column is country. We created a country column and we loaded this data. So we loaded this data into this partition. So this is statically partition, right? Static partition. So we loaded this data. So this is static load. We are using load to load the data, and we are basically using, you're doing static. So this is your static load partition. Okay, there was another partition, one other type of partition within the static, which is static insert partition. So what happens in this is what happens is we insert the data from a non-partition table to a partition table. All right, so in this case, instead of two files where we have America and India, we will have single file. So if I go back here, if I do an lsltr, I have a file called as countries. So this countries will have the data from both India and America. So if I do a simple cat, so you will have four columns here. First column is obviously your state, then you have capital, language, then you have the country code. So both India and America data is present in this particular file. All right, so here what we will do is this particular file. Now if you want to create a partitions on this, you cannot use load, right? Because your static load would require you to have a data of the column in a particular file. So if you want to do a partition on your country, then static load requires that you have a data of country India in one file, country US in another file, so that you can do something like this, right? You can create a partition and you say, okay, this is a partition and this is a file. So this is a partition and this is a file, but we don't have this file, we only have one file. So in that scenario, what we can do is we can use static insert partition. Okay, static load will not work, we'll have to use static insert partition. So what we do here is, first we create a non-partition table, a normal table, then we load all the data into this table. So this country's data will go into the non-partition table, and this table will now be our source. From there, what we will do is we'll create a partition table, and from the source table, which is a non-partition table, we'll insert this data into a partition table. There we specify the partition name. By this, we create the partition table with the required partition. And again, because we are manually doing all this is static partition. All right, so there are two tables which are required. One table is your normal table, which will store the data of the entire file. Then you create a partition table which will store the data of the partition. Okay, so let's do that. So let me go ahead and create a table. So I'm going to create an external table. Let's call it as non-partition table. I'll say non-partitioned table. The same columns I have the varchar of 255 for state. Then I have capital. This is again varchar of 255. Then we have a language. Let's take the same, and for country, okay, so this we can take it as 40 or something. All right, okay. Of course, these are row format delimited. Fields are terminated by comma. These are stored as text file. These are text files. So a location, let's use some location. Let's say non-partition table example. Okay, I think let's me use this same. Okay, let's go ahead and execute this. Okay, the table is now created. Now what we have to do is we have to load this file into this location. Okay, so I'm gonna say load data local in path, and what is my path? This is under Cloudera, under countries. So this is my file. Okay, and I'm gonna load into this particular table. All right, so this is great. So yeah, the loading is complete, and we have this data. So let me go ahead and check this. So here I should have this data. So let me clear this up and do an HDFS ls, and let me see if the data is available. So I have this countries files here. So if I do a cat, I should see the data from the countries. So it should have both India data and US data. So these are all US data, and on the top you have the Indian data. All right, so we have this data available. Okay, so one part is done. So we have the data what we want in this table. Now this will become our source table. Okay, so all the data that we wanted is present here. Now we need to create data from here. Okay, so let me create a partition table. So I'll say create external table, partition table on country. Okay, and I'm gonna use this will have a state, this will have capital and also language. Okay, now this is important. Okay, so you're gonna have just 3 columns, and the 4th column, which is your country, we are going to use it for partition. So we're gonna say partition by. Okay, so our source table has 4 columns, but then we are using just 3 columns, and the 4th column we are using as a partition column, so it will be here. Okay, so let me just copy this should be a row format delimited. Obviously the fields are terminated by comma. and stored as text file, and let me store this location somewhere. So I'm gonna say I'm gonna use this as a location. All right. Okay, so we have this executed. Now what we have to do is, here we don't have any data right now, so let me go ahead and execute this. So if I do NLS LTR or hyphen ls, I will see that there is no data here. Okay, now what we need to do is we need to load this data. Okay, so we have this table here, which is your non-partition table. So we can load the data from here to here. Okay, let's do this. So I'm gonna say insert into, so I'm going to insert the data into this table. Okay, and I'm gonna say partition. So my partition would be country equal to ind. Okay, and then I need to select this data. So I'm gonna say select state capital language from my non-partition table where country equal to ind. So I'm only selecting the country equal to ind data from my non-partition table, and I'm inserting into this table, which is a partition table. And what is a partition I'm using? I'm using country equal to ind. So all the data from this query, or which is basically it is going to get all the country code equal to ind, this data will go and sit in this partition ind. All right, let me execute this now. You cannot use select star, that is because your source table or this table has actually 4 columns, but we only need 3 columns, right? The fourth column we are using as a partition, static partition. We are giving the fourth column data here, country code equal to ind, right? So that's the reason why we are using the column names instead of select. All right, so cool. The data is now loaded. So what I'm going to do is I'm going to do the same for US. I'm going to say country equal to US, and yeah, so I'm going to say select state capital language everything, but here I'm going to say US. Okay, so I'm selecting the US data, and I'm placing this into this table, and I'm calling this, I'm giving the partition as US. So now country India data I have queried from the normal non-partition table and have inserted into the Indian partition. Similarly, from the US data I am inserting into the US partition. All right, so this is great. Now what I'm going to do is, if I go back and check this, so where is my table? So this is my table, right? So let me, before that, let me check this data here. Okay, so I'm gonna check this data here, htfs dfs-ls. So now you should see some files here. At the same time, let me also query this table. All right, so you should see some data. So you have the data, the India data, the US data, and if you see here, right, so these are 2 directories. So you have India directory, they have US directory. So if you query something like this, where you want to say where country equal to US, and it is basically going to hit this directory, sorry, it is going to hit this directory and it's going to give you that data. So this way you are not hitting the entire file system, you're not hitting the entire this parent folder, rather you are hitting only one folder, which basically gets your scanning by 50%. So that's how you can use the partition. All right, so this is about your static insert partition. So you create a partition, you create a non-partition table, you insert all the data into the non-partition table, that will now become your source, and then you create a partition table, you insert the data from your non-partition table into your partition table. All right, so that is how you do a static insert. So we have seen static load, we have seen static insert. Static load, you have multiple files, you use a static load. Static insert, you have one single file but you want to create multiple partitions using that file, you use the static insert. Now we'll look at dynamic load partition. So what is dynamic load? So dynamic load partition is that you don't give the partition name here. It will take automatically from the query or from the table. So first, data is loaded into a non-partition table, similar to your static insert partition, right? The data is loaded in non-partition table, and then the data from non-partition table will be inserted into the partition table. Same thing, right? So what is the difference? So the difference is that when we loaded this data, if you look at this data, we have specifically mentioned what is a partition column here, right? We mentioned, hey, you know what, this is the data from your non-partition table, insert into this table, but this is a partition. You have given that, you have statically mentioned it. Here in dynamic load partition, you will not mention it. So the partition table will be the partition column will be taken dynamically. So that's the only difference between your static insert and the dynamic load partition. Okay, now we'll look at the dynamic partition. Okay, now we'll take the same example. So what we're gonna do is we're gonna use the same countries file. So we're gonna use the same countries file that we have used for static insert. So we will create a non-partition table for this, the countries file, and what we will do is we'll insert this data from this partition non-partition table into the partition table, but this time we're not going to give the partition name. We will allow the partition name to be taken from the query. Okay, so that's the only difference that we're going to do. So let's go ahead and do that. Okay, so first step is, as usual, I'm going to create a table, and let me call it as source country. Okay, and it has 4 columns, as we know. It has state, and it has capital, and it has language. So these are the 4 columns that this countries file has. So I'll go ahead and quickly create those columns. All right, so we have language and we have country. Okay, all right, so we have these 4 columns. These are row format delimited, and these are separated by comma, right? So fields are terminated by comma, and stored as text file, and location. So let's say user Cloudera, and I'm gonna use this location. Okay, so great. So I have this table created. Okay, now this is a non-partition table. Now what we need to do is we need to load this data into this particular table. All right, so we use the load data concept. So I'm gonna say load data local in path. So this is under home Cloudera countries into table. So this is the table that we want to load the data into. All right, so if I do a select query, I should see some data here. So let me do limit 10. Okay, so I have this data. So if I go and check this directory, I should see some files here. I should see just one file, which is basically the countries file. Okay, so this is your non-partition table. Okay, so this is good. Now what we need to do is we need to create a partition table. All right, so we'll do that. So I'll go back to Hive, and I'm gonna create a partition table. I'm gonna say let me call this as target country, right? So we have source country, we have target country. So this target will have 3 columns, right? Because the 4th column, which is country, we're gonna use it as a partition. So I'm gonna have state, I'm gonna have capital, and the other column that we will have is your language. So we got 3 columns, and the 4th column we'll take it as partition. So we'll say partition by, and this is my column, which is country. Right, so give the data type. Cool. And of course row format, delimited, all the other things, you know, that we have to give. Fields terminated by comma, stored as test file, and location, I will say user Cloudera, and I'm going to use this location. fine. So this is great. So okay, seems to me there seems to be some error. Row format ted delimiter. Okay, there's some spelling mistake. This is row format delimited. Okay, I missed I here, so let me quickly correct that. Okay, so or what I'm gonna do is I'm gonna copy this here. I'm gonna open notepad, and yes, this way I'll just replace this, and I'll just correct what I have done. So row formatted delimited. Okay, this is the ones. Okay, so this is fine. So let me go back, and I'm gonna execute it here. Okay, so the table is now created, so this is good. Okay, now there is no data here, so let me go ahead and check this. We haven't inserted anything here, so there is no data. There should not be any data. Now what we have to do is we have to insert the data. So from the non-partition table we have to insert the data to the partition table. So in our source table we have a country column. In the target, the country column we are taking as a partition column. So dynamic partition will group all the country data from source and create a directory per group. So if you have let's say country code, in our case we have just two country codes, India and US, so it has to create two directories. But assume that we have 10 unique records or 10 unique country codes, then for each country code it will create a directory, so we don't have to specify that value. The query will automatically take care of it. Okay, so for that we need to write a query. So the query is let me write this query. So I'm going to say insert into my target table, and yeah, partition, I have to give partition. Now observe carefully, this is where things change. I'll just say country, I'll not say country equal to India or country equal to US. So in our previous examples, if I can take you there, here we mention insert into the partition, we mention country equal to US, country equal to India. Okay, now I'm not going to mention that. I would want the query to take from there. Okay, so what is the query? So I'll say select, I'm going to select the column. So first is my state, then capital language, and then I'm going to say country. Now what will happen is this country, what will happen is this country, this data will go and sit here in the partition. So if this country has 10 unique data, then 10 unique partitions will be created. That is how it is going to work. Okay, so from what is my table, I think is source country example, right? Yeah, source country example. Okay, this is my source table. Now this is a query that you need to do, but if you execute this, it is going to give you an error. Why? Because by default dynamic partitions are not enabled. You have to set this one property. Okay, so let me execute this. Now if you see here, right, it says dynamic partition strict mode requires at least one static partition column. To turn this off, we have to set this property. So this good thing here is that it tells you like, hey, this is a property that you need to set in. So I'm gonna say, I'm just gonna copy this here, and I'm gonna set this property. I'm gonna just copy this. Okay, now this property is set. So we have to set execute dynamic partition mode should be non-strict. Now what I'll do is I'll re-execute this query. So I'm gonna just copy it here, and yeah, now this time what will happen is your query will get executed, your partitions will get created. Now remember, we have not mentioned the partition name. That is important to understand. We did not mention in the partition name. It will take care from the query itself. So in our table we have two partitions, we have two country code, right? We have India, we have US. So it will create partitions for India, it will create partitions for US. Now if you look at this, right, so this is your logs. So it says loading partition India, loading partition US. There's another thing like Hive default partition. Now what it is suppose if you don't have any value in it, so those will be your default partitions, that's where it gets stored. But here the point is that it has created India partition, it has created the US partition, and we have not given any data, we have not given it any partition name. It has taken care from the query itself. So that's your dynamic partition. Okay, so if I go back and check this again, if I execute this, now you should see the India folder, you should see the US folder, also the default folder, which is should be empty, right? So let's go back and check this folder. Right, so you have a file here, and if you cat this file, you will only see the Indian data here. So yeah, so these are all the Indian data. Similarly, if you query the other folder, which is your US folder, so let me just query this. I'm gonna say hfdfs-ls, and this would give me the file which is present under this directory. I'm gonna cat that file. So this file, okay, let me copy it one more time. So this file should contain or will contain all the data that is belonging to the US. You can see here, this is all US data. All right, so your partitions are got created without you mentioning the partition name. So that's your dynamic partition. Okay. All right, so now important thing here is, let me go back. So if I do a select query on the select star from this, okay, now as I mentioned, if I do this, it is going to scan all the folders. So even if you partition it and then if you query something like this, it does not make any sense. Okay, just because you create a partition does not mean it's going to improve the performance. You need to make sure that your queries, if you are writing your queries are hitting the partition. So when you design the table, always understand, always make sure that a partition should be created on a column which is frequently used in the where clause. So if I do something like this, so this is a good case where I am partitioning on, I'm querying on a table, I'm on a partition column, I'm using a where clause. So this is important. So remember this, when you select a partition column, make sure you select a column which will be frequently used in the where clause. So that's an important thing you need to understand. All right, so okay, that is fine. Now let me go back to this data. So what I'm going to do is, let me just, if you look at this data here, right, so this is India data. If you look at this, the last column, if you'll see, this is language. So you have Telugu, you have English, but if you look at in other language, you say Hindi, you find it here, 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 here. English, you will find it here, here. You got Telugu here, you got another Telugu here. So basically what I'm saying is the data is basically within this, you have many languages which are common, right? So you can further partition, like for example, all English, maybe you can put it into one file, all Telugu you can put it into file. So you can partition it, you can sub partition it. So you partition on one column country, and then you can from that country you can further partition it. So that is your sub partition. You first partition on one column, the output of it you again partition it on another column. So that's your sub partition. All right, so we can do that. So for that, we already have the non-partition table, right? So we will use the same table, and then what we're going to do is we're going to create another partition table. So let me go back. So I'm going to say create external table. All right, I have three columns here, so let me quickly create those three columns. Yeah, so we're done with those three columns. Okay, this is partitioned by. Now here I'm gonna say country varchar, and then I'm gonna say language, so I'm gonna say varchar of 100. Okay, so what this means is, first the data will be partitioned by this field country, and then from there it will be sub partitioned using this column. All right, so we'll see this. Okay, before that let me complete this query. So this is row format delimited, fields are terminated by comma, stored at test file, and location is this one. Okay, okay, so we have this table created. So let me go here and let me clear this first, and I'm gonna do a hdfs ls, and this should be okay. So I'm gonna do an hdfs ls, and at this point it is empty, we don't have any data here. All right, okay. Now what I'm going to do is I'm going to insert this data into this table. Okay, so I'm going to go back, so I'm going to say insert into, and what is my table? This is my table, so I'm just going to copy it from here, and yeah, then we have to mention partition. I have two partitions, so where is this? The one is country, the other is language. So I'm gonna say country comma language, and yes, here you have to select state, capital, language. So these are basically your columns which gonna get inserted into this table. So state will go into this state, capital will go capital, language will go to language. Then you have two more columns, right, which is a partition, which is country and lang. So here, what is your country? I'm gonna say country, and what is your language? I'm gonna say language. Observe here, language is appearing twice. So these three columns will go and sit in this table with this, and these two columns are basically for your partition. All right, so from what is my source, let me scroll up. So this is my source. Okay, all right, so let me go ahead and execute it. Now what is going to happen is, from this source country example table we get state, capital, language, and the data will be divided based on country. So if you have two countries, so there will be two folders created, and then within each country, like for example India, you have multiple languages. Like, so if you have 10 languages, there will be 10 folders created under this country equal to ind folder. And on the other hand, for US, all of them are basically English, so there will be only one folder created. Okay, so if you look at this, right, so it says loading partition India. So under India you have language Hindi, then in under India there is Assamese, Telugu, Tamil, so many languages here. So all this data, all these folders will be created. So if I go back and I'm gonna do or execute this query one more time, so at first you will see that there will be two folders apart from your default folder partition. So these are the two partitions, one is country, one is US. So if I take a US, let me do an htfs -ls. So under US you have only one language, which is English, so you should see only one folder. So you see one folder here, language equal to English. So if I do query on this, so if I do a query on this, you can see that there is only one file. Okay, but if I do this query on India, so if I query on India, so country equal to India, so you will see there are so many folders under India. So these are all the country different, all the different languages that we have under India. So these are the sub partitions. So this is how you can create partitions. You can also create the sub partition. Now by default, each map reduce job will allow 100 partitions, that is 100 folders, including your partitions and sub partitions. If you want to change this properties, you what you can do is this one prop what you can do is you can change this property as this. So you can say hive execute and give a number here. So this number, it means that the default 100 is now changed to 500. So each map reduce job will now allow 500 partitions if you execute this. All right, so this is about your partitions. I hope this was helpful and exciting, and I will see you guys in my next class. Let's look at a use case here, a very simple use case. So I'm at the MySQL database here. So I have a table called customers where I have customer ID, first name, last name, email, password, street, the city, state, and zip code of the customer. So my use case is very simple. What I want to do is I want to import this data as a Parquet file, and then I want to query this Parquet file from a Hive table. There are two things involved. You have to first import this data into HDFS, and from there you want to query this data. Now, to import this data from a relational database into HDFS, we use something called as scoop, right? We have already seen this, right? Now, once we have this data, now we need to import it as a Parquet file. Remember this. Once we have this data in HDFS, we have to create a Hive table on top of it, and then we have to query this. It's a simple use case. So here I have the command. I'm not typing it because we have typed it many times. So this is a scoop command. So we have the scoop input. We have the connect JDBC drivers, the username, password, the table name, the target directory, and of course we have as Parquet, right? So let me change this directory. I think I have used the same directory again. Okay. So this is your Parquet file. This is how you are going to import as Parquet file. So let me execute this scoop command first. Okay, the scoop command is now executed. We retraced 12,439 records. So let me go ahead and check this directory. This is where we have imported the file, and we have imported this on the Parquet. You can see here, right? This is the Parquet file. So if you do a cat, we have seen this as well. We will not be able to view this data. This is a serialized data, so it's not in readable format. So this is how the data is. So let me clear this. Now what I'll do is, what we have to do is, we have to create a table. So we'll create an external table. So these are all the columns in that table. It's a row format delimited. It's stored as Parquet. So this is important because your file is stored as Parquet. So you say store at Parquet, and you specify this location. So let me copy this, and I will execute this on Hive. All right. So we have this data. We have executed this data. So if I do a query on customers, let me limit this to 10. Right. You can see the data here. Right, simple data. Let me also do another query. My first column name is customer ID. So I could say, let's say 10. I want to see the customer details of 10. Right. So we have this data. All right. So we can do almost all the queries that we do in SQL. So let me just do a group by query. So let me see where I can do a group by. So I can do a group by on state. Right, select a state. I want to see the number on each state. So a count star, and the table name is customers group by, and this is the table. This is where I want to group on, right? So it will execute your map phase, it will execute your reduce phase, and then it will give me the final. Right, so we have this data. So we have AL appearing three times, CO 122, TE 23, and so many other data we have. Okay, so this is a very simple use case. I just wanted to club both, a scoop and Hive, and if this is something that you can get it in a real time as well. This is kind of a very frequent scenario when you have the data in relational database and you want to basically import this data and query this data. So Hive is one of the tools that you can use. Next, in the next few lectures, we will look at features of Hive. Thanks for watching, and I'll see you guys in my next class. Hello and welcome to another session of Hive. So in this session, we'll talk about Hive bucketing. So what is bucketing? So bucketing in Hive is basically concept of breaking down the data into ranges, which are called as buckets. Now this is to give extra structure to the data so that it may be used for efficient queries. Right? This is the definition of Hive bucketing. Now let's understand it with a simple example. So imagine that you have some data in a table and one of the column is ID. So let's say these are the IDs that we have. We have from 1, 2, 3, 4, all the way up to 1 million records, right? So we have 1 million IDs. Now, every time you want to query something on this ID, it has to scan all those 1 million records, right? So what we can do is we can further divide them into ranges and then call these are basically called as buckets. So basically, let's say if I want to divide this into 5 buckets, so I'll have one bucket here, I'll have another bucket 2, 3, 4, and 5. I have 5 buckets. So now this data I have to divide into 5 buckets. So what will happen is each record, each record there will be a modulus operation. So if I take as this one, the first record is basically one modulus the number of buckets, which is 5. So the output of it is basically 1. So this will go into the first bucket. Let's say this will go here. So this will have the data 1. Similarly, let's say second record, and now here the modulus of 2, 2 modulus 5 is basically 2. So this will go and sit here. Similarly, this record, the modulus of 5, this will go and this is going to sit here in this bucket, right? Then this record is modulus of 5, this might go and sit here. Similarly, this is modulo of 5 is basically 0, so this might go and sit in the other bucket. Again, you will have another records which is 6. The modulus is 1. So this might go and sit here. Again, this might go and sit here. So what is happening is the data whose modulus is same, like all the modulus of 1 is will go and sit here. So it will have 1, 6, maybe 11 and so on. Similarly, all the modulus which of 2 will sit here. So basically, we are dividing this data into each of this bucket. So now if I do a select queries, let's say select where ID is equal to 10. Now the ID 10 would be the modulus of this one would be 0. So this ID 10 would basically be sitting in this particular table or in this particular bucket. So when you query this particular ID, this is directly going to go and search in this particular bucket now rather than all the other files. This way, we are going to avoid a full table scan. We are limiting the scan to only just buckets. So this is where buckets are useful. Now, these buckets are basically not that common because this is again used only when you wanted to query predominantly on a particular value on particular range of values. Like if you have, in this case, on the IDs, you are always querying on this IDs, that is where you want to create a bucket. But if you're using any other queries, let's say you're not using a where clause on ID, you're using some other columns, then the bucketing will not be that useful. All right, so enough of this query. So let's go ahead and understand this with an example. So I'm going to the MySQL, and if I look at the tables here on the retail underscore DB, I have multiple tables. So let's pick this table. So let me describe this. Now I have order ID, order date, customer, order customer ID, order status. So order ID is basically primary key. So what we will do is, let's check this data first before. All right, so we have good amount of data. We have 68,833 records, and the order ID is basically ranging from 1 here, right? So what we will do is we will enforce this bucketing on this particular column, which is order ID. We will create buckets on this ID, right? So for that, let's jump on to the Hive session. So I'm here at the Hive session. Now, in order for bucketing to happen, we need to enforce some properties. So first property we need to enforce is this has to be a dynamic partition. So we have to make sure our dynamic partition mode is to non-strict. And the other property that we want to enforce is we have to say hive dot enforce, then bucketing. This has to be true. These are the two properties that we have to enforce. Now, when you are enforcing some, when you're setting up some properties, make sure that you see that you have the proper value set, and also make sure that you are writing the right spelling, right? See what happens here is, even if you look at this hive.enforce or bucketing or any of this, right? If you misspell any of this, it will not throw any error, and that's something that is kind of not a good thing, but that is how it is. So it will basically take as it is, so you will never know what mistake you have done. I've seen people say, hey, no, I set this property, that property, but somehow it is not working. Now why it's not working, there may be different reasons, but one common reason, when they set some properties, they have misspelled it. So if, let's say, if I put something like this, instead of bucketing, I say bucket, and I give it as true. See, this is not correct, but still it is not giving me any error. So please make sure that you have the proper spelling put, and if you set up some property and see that it is not working, make sure that you come back and verify what properties you have set, if it is on the right spell, if you have spelled it correctly or not, right? So this is something that you have to keep in mind, right? So now let's create a not partition table. We'll create a table on the orders. So we'll recreate this in the Hive, right? This order table. Okay, I have this table here, the structure of this table. So basically we have 4 columns. This is a row format delimited, again fields terminated. We are storing it as a text file, and the location that we want to store is this one. So this is the location. Here we have this data. We already have this data. So if I just query it, this is the data that we have loaded at the beginning. Right, so we have this orders.csv, and you can cat this. So we have this data on this location. So what we're going to do is, let's go ahead and execute this table, create this table. So let me go to the Hive session, and I have this table created. So if I do a describe, let me do a describe formatted so that we have all the details at one go. So you can see here the column, all the column names. This is under the database practice, and the owner of this table, it's an external table with this location. The data is already present. We have seen this data. This is great. Now what we will do is we'll create a partition table on the same orders column, on the same orders table. So we have this query here. So what we are doing is we are taking the order ID, order date, order customer, order ID. These columns we have, and we are creating a partitioned column, partitioned by. This is on order status, and so this is what we are adding again. So once you partition by order state, you are clustered by order ID to five buckets. So this particular piece of code tells you that you want to divide this range's order ID into five buckets. So what will happen here is, first it will create partitions based on order status. So let's say we have five order status. So it will create five different folders. Under each folder, what it will do is it will look at the order ID. It will do a modulus operator on order ID, like say order ID modulus 5. And then whatever is satisfying this modulus, all the corresponding modulus say values will go into one bucket. Let's say a bucket one will have a modulus 0. So your order ID 5, your 5 modulus 5 0. So that will go into first bucket. Similarly, order ID 10 will go into first bucket. 15 will go into first bucket. So this is how it will go. So let me go ahead and execute this query. So we have the query executed, and right, the location here, we don't have any data. We just gave a location. Now we have to insert the data into this location. Now we have the data in this table, orders table. So we will insert the data into this orders bucket from this orders table. So I'll have a insert command, insert into this. This is a partition table. So I will use partition. I'll have one partition order status. This is a dynamic partition. So we don't have to specify any value here. So let me go ahead and pull this data. So I will need order ID. Next would be order date, order customer ID. And of course, we need order status from order. Is it order or orders? Yeah, this is orders. Okay, good. So let me go ahead and execute this. Each order, so now we have, now because we are segregating the order ID into each of these buckets, so it has to go through a comparison, right? So for each folder it has to go through a comparison. Because of this, there will be five reducers that will be invoked here. So you will have five reducers. This will this will cause the program to run little slower, because there is a shuffling of data that is happening into this five buckets. So you might find this take a little bit more time than usual, but that is okay. That's because you have five reducers running here. Yep, you can see here the number of mappers is 1, but the number of reducers is 5. This is because of the shuffling thing that is happening here. All right, so we have the data loaded. It took just 65 seconds, a little over a minute. Now, if you look at this, right, now first what it is doing, it is loading into partitions. So these are the partitions that got created. And once this partition got created, inside this partition, if you see, for example, this is a partition cancel, right? Order status is cancel. Inside this partition, you have number of files as 5. So this number of files is basically number of buckets. So under each partition, you have 5 buckets created. So let me go ahead and query this particular directory. This is where we have the data stored. So let me clear this. So first we have the partition. So I will go ahead and query this partition. Now you can see here, right? This is 1, this is 2, this is 3, 4, 5. So we have 5 files. Now these are basically buckets. If you look at any of these buckets, and if you look at the order ID, you will see that they all, if you do a modulus operation, the result will all be the same. Okay, let me take this one. Now, if you see, right, this first column, so all of this, if you do a modulus operator, all of this requires the modulus operator, the result will be zero. So this is why all of them are in this bucket. Now, if you take other bucket, let's pick this bucket. So if you look at this, right, the modulus operator, all of them will have the same modulus operator. So that is why it all ended up into one similar bucket. So what happens is when you query something on the order ID or on the order ID, then it will look for the modulus, right? It will do a modulus and it will know like, okay, this is the output of this modulus 0. So therefore, I just have to check this particular directory. If the or this particular file, if the modulus is 1, I'll have to just check this. Or if the modulus is 2, I have to check like this. So this way, instead of going through the entire files or entire directories, we are limiting that to buckets. Now, so this is the advantage of using the buckets. Now we have created this bucket using a partition, but partition is not really a necessity. You can still create these buckets without a partition. Probably that is something that you can try. So here you can just remove this and put it here, and then you can create a table without partitions. All right, that's all for this session. I hope bucketing concept is clear to you, and I'll see you guys in my next class. Hello and welcome to another session of Hive series. So in this session, we will see how we can handle the schema changes. So imagine this scenario. So you have a Hive table and you're getting this data, and now your Hive table has some particular schema. Now the source team has made some changes to their schema. So basically they have added a new column or they have dropped a column. Now every time they make some changes to your schema or the other source schema, from your end, you will also have to make the same changes to your Hive. If you don't make those changes, then the data might get messed up, right? And then we will see how it happens. So what we will do is we will try to replicate that scenario here and see how Hive is behaving. And then we will talk about what what we could have done differently so that these schema changes can be handled very effectively. So we are here at the MySQL. So we have a table called test which we have created. So it has three columns: ID, name, and city. So let me first delete the data from this table if I have any data. So I might have added some data while testing. So we don't have any data now. So what I'm going to do is I'm going to insert some data into this table. So I have the insert statements here, a simple insert statements, and I have inserted this data. So let me just query this data. So I have IDs from 100 to 104, 100, and the name John, Pooja, Michael, and Jesse, and these are the cities where they reside. So I have this data. Now what I want to do is I want to import this data into HDFS. Now we know to import this data into HDFS, we can use scoop, right? So we can write a simple scoop command to import this data into HDFS, but this data, this table is going to is going to add more and more data. So this is basically today we have 4 records, tomorrow we may have 2 more records coming in. So this is basically kind of an incremental append or incremental load. So for that, a better way to do is to create a scoop job, right? So I have this scoop job here created. So you have a scoop job. This is my job. I think we already have job 1. So let me change it to job 5. So this is my scoop job. I'm connecting to the JDB using the JDBC drivers. It's in retail underscore TB. The table name is test. We don't have to use split by here actually, because we are just taking one mapper. So we didn't need to do any split by. The target directory is test3. It's an incremental append, and the column is basically ID. and the last value is 0. So this is a scoop job. So let me go ahead and execute the scoop job first, right? So the scoop job is now created. Now what we have to do is we have to execute the scoop job. So I will say scoop job execute, and I have to give the name of my scoop job, which is my job file. So it asks you for your password, give the password cloud area, and my scoop job is going to get executed. So it is going to import this data from MySQL into the location which is specified. Great. So my scoop job is now executed. So if I go back and check this directory, right, I should have this data, right? I have one file. So let me go ahead and get this file. The small file which should contain just 4 records. So we have all these 4 records. So now what we will do is we'll create a Hive table on top of it. I have the Hive table query here. So we are using the table called as test1. These are the ID, name, and city, the column names. And so this is the location. This is where our scoop job is inserting or loading this data in. So let me go ahead and query this Hive table or create this Hive table. So the Hive table is now created. So if I query this Hive table, I should see those data. And the MySQL is our source table. So in the source, we have some data, and our scoop job is running, which will import this data into HDFS. And then using our Hive table, we are basically querying that imported data. So this is, imagine this is something which is going to run every day, schedule every day. So this is good. It is, we are doing it correctly, and things are running fine. So what is going to happen is, let's say, the next day, we have 4 records, right? We have 2 more records that gets inserted. So what we do is our source table has 2 more data, 2 more records. So if you do a select, you will see that now it has 6 records. Now, once this data is inserted, we will have our scoop job. Now our scoop job is going to run, and our scoop job is going to execute, and because it's an incremental append, it is going to bring those 2 records and insert into the location. So now those 2 records will be available in that location, and then your Hive is going to query those 2 records. When you query the Hive table, you should get those 6 records. So this is the normal data flow that is happening at the system, right? So let's just wait for this query to get completed, and then we will verify this. So we have the job, scoop job executed, and this is the place where we have the files being inserted or loaded. So as you can see, this is the new file that got added, and it should have those 2 files or 2 records that got inserted into the MySQL database very recently. So these are the 2 records that we inserted. Now the same thing will work for Hive as well. If you query this, now here we had data till 104, the ID 104. So you should have the 2 more records. So this is absolutely great. There is no issue here. Everything is working perfectly. Now what is happening is, if you look at this, this is our source table. So what source table has done it, they deleted this particular name. Okay, now this particular column name, they have dropped it. So let's drop this. So we'll say alter table test drop column. This is name. So we have dropped this column. So if you query this table, right, we have just ID and city. So New York, Mumbai, London, Cochin, Mumbai, and Cochin, right? So this is the data that we have. So the change has happened at the source side. Now what will happen at the target? So if you go and query this target, So it is still showing those three columns data, which is anyway, it is fine. That should not be a problem. But let's say we have inserted two more records here. So now here we don't have name, right? We just have city. So let's say we have this value, maybe let's say that we have this value as 107, and we have this, let's say we just insert mobile. I want to insert one more record here. I will call it as New York, or let me call it as London. So we have two records here. So when you do a query here, you will see, like, we have eight records. So the next step in our pipeline is our scoop job, right? So we'll have to run our scoop job. So let's give the password here. Let it ask. Okay. So we have the scoop job running. Now this scoop job is going to take those two records which are recently loaded, and it is going to put it in the HDFS location. All right, so we have this scoop job successfully loaded, so let's go ahead and check this data. So we have the new file here. So if I do an HDFS here, and I cat this, I should see just two records, but at the same time, we'll only have two columns instead of three columns. So this is fine. This is what we have expected. So there's no trouble here. The trouble comes in the Hive. So when you query this table in Hive, you will observe something here. Now you see here, this is supposed to be your ID. This is supposed to be a name. In your two records that got recently added, so you have name as Mumbai and London. This is not correct. The name is not Mumbai. There's no name. We have dropped the name, but Mumbai is basically your city. This value should have been here where you see null. This value should have been here where there is null. Now this happened because we have a schema change at the source, and we did not make any changes at target. What you can do is you can create another table which can refer to this location, and then you recreate this table and basically load this data from that table into this table. But that's something we can do. But there is a better way of doing this. We have to make use of Avro file. Now remember, during our file formats, I mentioned that Avro is something which helps in schema changes. It's very good in schema evaluation, right? So let's understand that with an example. It's time for us to make use of the Avro schema evaluation capability. Let me go back to this, and let me see what tables I have. So let me create a table again. All right, so we have a table called test stage, and we are going to insert this data into this test stage. So we have these four records. So what I'm going to do is I'm going to go ahead and insert this data. So if I do a select star, I should see this data. So this is great. So we have this data. Now the next thing that we want to do is we want to scoop import this job, right? So now when you scoop this, import this job, we have to make sure that the data or the file that is generated is Avro. So we need to import this as an Avro data file. So here is a scoop job that will create. So let me call this scoop 6, my job 6. So we are doing an import, we are connecting it, and we are basically doing an incremental append. Check column is basically ID. we are importing this as Avro data file. Now this is very, very important. You have to import this as an Avro file because Avro file supports schema evolution. If you import this as a text file, this will not work. You have to import it as an Avro file. So what I'll do is let me go ahead and let me clear this up first, and I'm going to execute this. My scope job will get created. Yes, it got created, and I'll straight away execute this scope job. All right, my scope job is now executed. So let me quickly check this directory. This should have this Avro file loaded. So you can see here the Avro file. It has imported it as Avro file. Now what we have to do is we have to create the Hive table on top of it. Now, when you create a Hive table here, the difference is you have to put the schema in what is called as .absc file. Instead of passing that schema while creating a table, you basically mention the location of a file, and this location you should have the .absc file. The absc file will contain the schema of this table. Now, you can basically Google and check for the format of the ABSC file. Or what you can do is when you do a scoop import, you know that there will be .java file that gets created, but there is also something called ABSC file that gets created when you do a scoop import on Avro data file. So if you look at this file, it will contain the schema details. So if you see here, these are the fields. You have name, which is ID, and then we have the type, which is integer default values and other stuff, right? So similarly, we have for name, you have for city, right? And here it specifies this table name. So this is a file that you have to pass instead of the column names. So the schema for the table you have to refer from here. So let's copy this file to a Hadoop location. So I'm copying this to user Cloudera. The file in the user Cloudera Hadoop location, and this is the contents of this file. So now what we have to do is we have to create a Hive table. So let's create this table. So we'll say create table. Let's create an external table. And let's give it a name, stage 1, text stage 1. Now, normally we would have given the column names and other stuff, but here what we'll have to give is we'll give as row format 30 because this is serialization, right? Because we are using the Avro file, so we have to use the Avro serialization library here, so which is in org Apache Hadoop x32 Avro. This is a 30. Now you don't have to remember this. This is something that you can get it in Google or from the Apache website. So don't try to remember this. If you can remember, that's great, but it's not necessary that you have to remember this. Now we have to store it as Avro. Location is let's say user Cloudera This is where we want our data to be. And here, this is important. You have to mention the Avro schema URL. So you'll say Avro URL. So this is where you have to mention the Avro schema URL. So where do we have this Avro schema URL? So this is the location of the Avro schema. So we have to mention this. So now what happens is the table is going to check the schema available here. So whatever schema which is available here, your Hive table will use the same schema. So if there is a change in the schema, all we have to do is we have to change it here. Once we change it here, the updated schema will be referred by the Hive table. All right. So let's go ahead. We have this data. We have the table created. Let's check this. Seems like some issue. All right, the issue seems to be something different here. So if you see this, this is I'm at the edge node. If you see here, I have three records, three columns here: ID, name, city. But at the HDFS location, I somehow have just two records, two columns. Probably this is something from our previous example. So I'll have to copy this again to the HTML location. I believe I missed copying this, so that's the reason why you end up seeing this. Okay, so I guess I'll have to first delete this. So let me go ahead and delete this. Okay, so let's just verify this one more time to make sure that we have the right file here. Okay, we have the columns, all the columns here, so we are good here. Okay, so we have this data now. This is a new schema that we have, right? And let me go ahead and execute the Hive table. Now, again, this is a good example as well, even though we did mistake. So if you look at this, where we in the Hive table. So when we did a select star on stage one, because it refers to this schema, the schema we had just two columns, right? Now we have corrected the schema. So if you go back and check this, now we have the right results. So as we change the schema, so if there was a change in the schema, you just update this AVSE file and everything will look good, right? So earlier we had just this records. Now we have corrected the schema and it all looked good. Okay. Now what we'll do is we will delete this data. We'll delete a column here. Alter table name. So we will drop this column. And what we are going to do is we are going to insert two values. This is ID city. Values would be let's say 107 would be London. Let me add it as Hyderabad. All right, so we have this data. So now what we'll have to do is let's execute this scope job. Okay, I'm going to execute the scope job. So this is scope job is an incremental job which is going to retrieve those two records. Now remember what happened here is that we have a column dropped, right? We deleted a column from the source side. So the scope job is going to retrieve those two records, but those two records will have only two columns. The column name is basically missing. And this is the earlier scenario we have seen, right? So we are replicating the same scenario, right? And if I go back and query this table on Hive, now what I will see here is, now as you can see, for 107, you have null record here, right? The London is basically under the city, right? So this is how we are able to rectify this. Now, earlier, without the ABSC file, this London would have come here under the name. But now, if you see here, all of them make sense. We didn't have anything for the name, so we have null. We have data for the city, so we have this data here. Now let's say if you, because name is deleted from the source table, we don't want to see name here. So what we can do is we can basically go here. We can open the AVSC file, right? So this is the AVSC file. And here what we have is we have name, we have city and other ID column, right? So name is not present. So what we can do is we can basically delete this, everything related to the name. So once you delete this, now this at this time, so what is happening is now here you have two columns. One is ID and city. So let me go ahead and save this, and we'll have to copy this to the HDFS location. So we forgot it last time. So we have copied this to the HDFS location. Okay, we have the file here. So let me delete this file first, and then we will copy this file to the HDFS location. So this should work. Okay, we have this file. Let me cat this file and make sure that we have the right set of metadata, right set of columns. So we have just ID and city. Now, the Hive table that we created using the .absc as the schema, right? That table will refer to this schema and it will say, hey, we just have two columns. So when you query this Hive table, now it will only display those two columns. It is not going to display those three columns. You can see here, right? It displays only two columns. So it is very easy to, make the changes. You don't have to drop the table. You don't have to recreate the table, anything. All you have to do is you have to go to the AVSC file, you delete the column, and that column will not appear here. If a source adds a new column, you just go to the AVSC file, you add that column, and then you push it to the HDFS location. Your table will pick up this data from the HDFS location and it will displayed accordingly. So this is so easy. This is how we can do a schema evaluation. We can support the schema changes. So any project where your source is continuously changing the schema, adding a new column, deleting a new column, making the changes in the schema, maybe data types and anything else. So in those scenario, an Avro data file would be the right choice, right file format for you. And we have seen how easy it is to make changes to the schema. All you have to do is update this newly changed schema into the .absc file and then push it to HDFS. There is no other changes required. I will automatically pick up the newly changed schema from the .absc file and it will display whatever is as per the .absc file. So that's it. We have made few mistakes here and there, but that's also good because these things can happen in real time as well when you're working on the project. And if you have a similar issue that has come up like we did, so right at that time it will be easy for you to recollect and say, hey, similar kind of issue happened in the course. So it's easy to resolve those issues, right? We always learn from our mistake. So that's it for this session. Thank you for listening, and I'll see you guys in my next class. And welcome to another session of Hive. Now, for executing the Hive queries, we have basically went into the Hive shell, and this is where we are executing the Hive queries. Now, if you're not in this Hive shell, you can still execute this queries. For example, I'm right here at the edge node. So if I want to execute something and a Hive, I can basically say Hive hyphen e, and then I can basically put the commands here. So let me say I want to select some data from this database, and I can execute this. It will invoke the Hive shell, it will provide the results, and it will display it on your screen. Right, I think there's no data on stage. Let me check if there's any data on stage 1. Yep, you see the data here. So this is how you can query the data from the command prompt from the edge node here without even invoking the Hive shell. Now extending this, you can also execute the Hive queries from a file. So what you can do is you can take all the Hive queries that you want to execute and you put them in a Hive in a file which the extension .hql you can base, and then you can execute this file. So when you execute this file, all the queries that are present in that file will be executed one after the. So what you see here, I have a few queries or a few commands. So basically, if the first is to create a database demo one, then we use this demo, the demo database, and then we create this tables. Let me call it as demo 2. We create the table on demo 2, and then we describe the table and we load the data into this table, right? And then we do a select star. Now I can execute this one by one on a Hive shell, or what I can do is I can put all of them in a single file and execute them. So I'll do the later because we have anyway executed one by one. So I'll go to this place here. Let me create a file. Let me call it as let's say file test file script. It has to be an extension of HQL. I will add all these details here. Now this file has the details or all the commands that we want to execute. Now to execute this file, I have to say hive-f, and then I have to give the file name. So when I execute this, when I query this, it will execute each one of it one by one. So the first it will execute this create database command, right? It has executed. So if you go back and check, I'm not sure if you can go back here. We got quite a lot of data here. Yeah, will not, you don't have this, but basically what is happening is it has created all this command. So we have this database created, we have this table created, and then there will be describe formatted. We loaded this data here, and we queried this. You can see the query select star query data that has been displayed. So you can verify this database. So let me go to Hive and let's say show databases. So you have the demo 2 created here. So if I use the demo 2 and if I see the table, you can see the customer table created here, right? So this is a very useful way of executing all the queries in one. So generally what happens is in production where you have to execute all these queries, if you we will create a shell script something like this. We put all those details here, and you can basically call the script and you can run the script, you can schedule the script. So when the time is up for the commands to run, it will execute on its own one by one, and it will give you the required results. Now the one thing that you have to remember here is suppose by the commands that we have given, let's say at second command or third we have like 10 commands. Let's take for example, if second command is failed, then it will stop right there. It will execute the first successfully, it will stop at the second, and remaining commands will not get executed, right? So this is a simple way of how you can execute these commands from a file. And I hope this was clear, and I'll see you guys in my next. Hello and welcome to this session. In this session, we look at some of the Hive date formats. Now, the default date format in Hive is YYYYMMDD. That's the default date format. And then we have the different date functions that we can use in Hive. So let's look at each of them. The first thing that we have is the Unix timestamp. So this will basically return the number of seconds from the Unix time. So that's the Unix time 1970-001, and it uses the default time zone for conversion. Then we have from Unix time. So this is primarily used in conjunction with the Unix timestamp. So when you have the result from the Unix timestamp and you feed it to the from Unix time, it will convert it and it back to the desired date format. We'll see an example of that. Then we have the to date format where it just gives the date in the form of YYYMMDD, which is the default date format. Then we have year, month, date, hour, minutes, and second, basically to extract the year part or month part or day part from a particular date, which is in string format. These functions are used. Then we have something called as date difference, which will return the number of days which are different between the two days. You have 2 days, you give two dates, and then a date different will give how many days are different in each from the two. Date add and date sub are basically to add the number of days and to subtract the number of days from a specific date. So we will try few examples and understand them. So here I have a few of the examples, and this will be available to you in the article section. So the first thing that we have is Unix timestamp. So this will basically convert this into seconds. So let me go ahead and execute this. So these are the seconds that we have. Then we have the from timestamp. So if you use this from timestamp, so you will see it convert back to the desired date format. And and then we have something called as to date. So if I do a to date, it has a timestamp as well, but it will give me the date, only the date value. Then of course, if you want to extract the year out of this, you use the select of year. There you go. 2020 is the year. Similarly, if you want to select the month from here, then you get the month as well, which is 2. And if you want to do a date, then you get the day here. And this is basically you have the Unix timestamp, which is fed to the from Unix time, which will give the entire date, and from there we are picking the year. So you will get the year as output, which is 2022. So in a way, if you query this, let's say select from Unix timestamp, so it is going to give you the current date. So this is kind of similar to a sys date in your Oracle, right? And of course, the difference between the dates, if you wanted to find out how these two dates are different, and the result will be in days. So they are different in by 9 days. And if you want to add, let's say you want to add 5 days to this, what would be the output of that? It would be a new date, which is 2003-06. So it was 1, and we added 5 days, and which makes it 6. Similar to that, we also have the date sub. It will basically subtract 5 days from this date, and it will give you a new date like this, right? So these are some of the Hive date formats that we have, and date sub, date add, date difference, and to date are something which are very commonly used sometimes. The year, month, and in fact, most of this, all of these are very commonly used. I put a separate session for this, although it's a very small session. I just wanted to point out this because dates are something which are very predominantly used everywhere, and Hive also supports the dates, but they are a little different from your normal SQL dates. So I thought that this would be a nice time to introduce you guys to the dates. I hope this was interesting, and thanks for listening, and I'll see you guys in my next class. Hello and welcome to another session of Hive. So in this session we'll talk about joins in Hive. Now similar to your relational database, Hive also supports all types of joins. You can have your inner joins, the outer joins, left outer join, right outer joins on the tables. Apart from that, there are a few other joins that Hive will support, but let's try some joins that how you will try in your normal relational database. So I'm at the MySQL database. Here I have certain tables. Now we already created the order tables at the Hive. So let me just go ahead and check this table. So I will limit it to 10. So we have some data in the order table. Now there's another table which is order items. So we have other table called as order items. So I'm not sure if we have created the table, but let me check this. We have not yet created this table. So let's do something. Let's create this order items table, and then we will query the order items table and order ID order tables using joins. So if I describe this, I have order ID, order date, order customer ID, and order status. This is for orders. And if I do an order items, I have order item ID, order item, order ID, product ID, quantities, subtotal, product price, right? So I have order ID here, and the same order ID we have it here. So that will be used for a join purpose. Okay, so let's go ahead and create this Hive table. So we will create an external table. I'll give the schema here, and I have to copy all this, so let me quickly do this. This will be int. We have our product ID, which will be again int. Then we have item quantity. We have item total, subtotal, which is float, and in Hive it will be double, and item price is again float, so we will take it as double. So these are the columns that we have, and of course you have to give the format. It's row format delimited, and your fields are terminated by comma. So we are going to use the data. We are going to basically use the file that is already present in the Hive location. It's in the Hadoop location. Remember, all the 6 tables we have copied to the H location. From there moved it in, or we copied it to the HDFS location. So we will use that because we have created an extended, we are creating an extended table, so we'll use that location. So back to the topic, our fields are terminated by comma, and lines are terminated by slash n, which is new line. This is stored as a text file. All these are text file, and the location is it's user Cloudera I data sets, I believe data sets, and I think it's order items, but let me quickly check that. Let me verify that it should be order items, but it's better to verify this once. Yeah, it is order items. So all right, so let me go ahead and execute this. All right, so we have the table created. So I'll quickly check this data. Let me limit it to 10. Okay, so I have this data. So what I will do is I am going to, let me also query the data on orders and have it ready here, so you can see that on screen. All right, so what I'm going to do is I'm going to select some of the column data. So let me pick up from O is my orders table. So, and if I go back here, what do I have in orders? So I have order ID, I have order status and order date. So I'll pick up order ID from here, and I will also pick up order status, and that's the two columns I need. And then OD is basically my order details. So I will pick up just one column. Let me pick up what do I pick up? Let me pick up the order item product price. Okay, this should be good. So yeah, I just need few columns. I just wanted to try the join condition, that's all. So this is from orders O. Let me try inner join. So order items OD on. So this would be order ID, which is on order, and this would be order items order ID. All right. Okay, so let me execute this. So this failed, and the reason for it failure is we need to set up some property for join, right? By default it is going to be true, so we have to set it for false. So let's say hive dot auto convert dot join is equal to false. We have to set this false. By default it is true. So what is the meaning of this, what it does mean? So when it is true, and when the table size is less than 25 MB, the joins are auto converted into map based joins, and we will see what map joins are, what map based joins are in a little while. But this is what it means. If it is true, it is basically saying that if you find something which is 25 MB or less, it is going to convert that join to map based join. So we are not executing a map based join here, we are executing a normal query. So we'll have to convert this to false and then go back and execute this query again. Now this is executing, and you should see the results in a while. We have this data here, and for this we have mappers as well as reducers invoked. So there is a data shuffling that is happening. We can also put a left outer join, right outer join, all these joins will work. Apart from these joins, we also have few more joins. So are the joins that Hive supports apart from your normal SQL joins. So one is map join, second is bucket map join, then we have sort bucket map join and skew join. Now bucket map join, sort merge join and skew join is something which is not commonly used. It's very rare use, and again you have to set up a lot of properties to use this. But one thing which is commonly used is the map join. So how map joins work is, let's understand this with an example. So let's say you have two tables. This is table 1 and this is table 2. Let's call this table, maybe we can give it employee, and let's call this table as department, right? Now if you have to join these two tables, what map based join means is the table which is smaller, let's say this is a smaller table, right? Department table is always smaller. Now what will happen is when you're doing a join, the data from this table department table data will go and sit on the data node of employee table. So this is one time shuffle that happens. Now join will happen here and then the data will get released, right? So suppose if the employee table is in let's say the employee table is here, it is in data node 2, 1 and 2 and 3. So we have the employee data in 3 data nodes. All right, so this is the employee data. Let's say you have here we have the employee data in 3 nodes, and let's say this is your department table. Now during the map join or map join, what will happen is this data will basically get shuffled, and it will go and sit in each of this data node, and then the join will happen here, the join will happen here, the join will happen here. When you have a join, the join is happening on the same data node, so within the same data nodes join is happening here, right? So this way we can reduce the this way what happens is we can basically reduce the time it takes. Otherwise if it is into separate nodes, every record there has to be a shuffle just to make sure there is a comparison here and there. So that avoiding that, and this will improve the performance of the join condition. Again it is only advised if you are having a small table. If you don't have a small table, then it doesn't make any sense to have all those big tables go and sit on the other data nodes, right? So if you want to execute the map phase join, we just have to make one small change to our query. So this is, let's look at the query that we have. So this is the normal query that we have executed. Now what we have to do here is we just have to give the hint and say, you know what, this is map set join. So I have to say you have to give plus, and you have to say map join smaller table, and I have to close this. That's it. So if I execute this, it will execute as a map join, and and it will give out the result. You may not see significant changes here because both the tables are small, but then if you execute this query on a bigger tables, one is a bigger table, the other is a small table, you will definitely see a lot of changes. The earlier query executed in 29 seconds, and this time using a map phase join we got this result in 23 seconds. There is a slight improvement, but even there will be a lot more improvement every time if you one of your tables is really large, but still we can see some performance improvement when you use a map side join. So this is something which is very commonly used. Now the other type of joins are something which are not very commonly used, so I'm not gonna spend too much time on this because there are a lot of properties that needs to be set up, and something which is not really that common. But anyway I'm going to walk through what these are. So the first thing that we want to talk is bucket map join. So for bucket map join to take place, we have to set two conditions. First thing is both the join tables must be bucketed. So if you have two tables, table 1 and table 2, both of them should be bucketed. Again, we talked about what bucket is. We create the bucket, we basically divide the data which is in ranges into different ranges, small buckets, kind of small part files. And the reason why we do is if you query on a particular column on a range of data which is having a range of data on a regular basis, then it's a good idea to bucket that, so that your query will not go and scan the entire files, but will just scan the required buckets. So that's the first condition that we should have. Both your tables should have buckets, and the second condition is it should be bucketed on the join key. So if you have table 1 and table 2 and your join key is, let's say, id, you both of your tables should be bucketed on the id column. And the other thing is the number of buckets between two tables must be multiple of each other. So if, for example, if table 1 has 2 buckets, then table 2 must have buckets in multiples of 2. So that is, it could be the 2, 4, 6, 8, those many buckets, right? So these are the certain conditions that we need to have for the bucket map join to take place. And of course we have to set up two properties. We have to enforce bucketing, and we have to set hive optimized bucket map join equal to true. So when you have those two properties set, and then you have these criteria that I mentioned, then you can go for, then it will be called as a bucket map join, right? So this is the query here. Table 2 is basically the smaller table. There's no change from the previous query, but then the only change is the properties that we set. And both these tables, if they are having buckets, if they are bucketed and bucketed on the same id, and if they are in multiples of each other, then the query or the map join that happens is called as a bucket map join. That's the only difference, guys. There's nothing difference in terms of how we use the queries, but you on a preconditions, the bucketings and other things that I mentioned, those needs to satisfy for it to be called as a bucket map join, right? So this is how it works, the bucket map join. So let's say you have two tables. Table 1, let's say it has 8 buckets. Table 2 has 4 buckets, right? So what will happen is the similar buckets will go to the same mapper. So if you see here, for table 2, again buckets are based on modulus, so you will have 1, and then the for bucket 2 you may have 1 and 5 buckets where the modulus is same. So this data, the records which are in bucket 1 in table 2 and bucket 1 and bucket 5, so they will go into the same mapper, so they will do the join from there. So this way we are basically joining the corresponding buckets, instead of one bucket going and joining with the all the other buckets, right? So this is how the bucket map is join happens. So the join happens within the buckets, and these buckets will have the similar data. So you will have the same kind of ids, and you can basically join in within the buckets. This is another illustration how the bucket happens. So if you see bucket 0, it only just goes and does the map side or does a join on bucket 0 and bucket 4, because basically these are the same buckets which have the same modulus, right? And similarly bucket 1 will go for bucket 1, and it will go for bucket 5. So this is how the bucket map join happens. So join happens within the buckets, right? So the next join is the sort merge buckets join, and this is very similar to the bucket join what we have seen. Now in what is the difference is there's only one difference. In bucket map join, data is not sorted. So before you join, the data is not sorted, and if you want to sort the data before join, which is a good practice in general. So if you want to if you want to first sort the data and then do the join, then you use a sort merge bucket join. That's the only difference between the sort merge bucket join and the bucket merge join, or the bucket map join. And of course there are some additional properties we need to set. So these are the 4 properties that we need to set in order to make sure that we have a sort merge bucket map join. All right, the next is the skew join. Before understanding skew join, we need to understand what is data skew. So data skew is primarily refers to the non-uniform distribution of data. So this basically means that some values appear more than others. For example, let's say we have this table, we have the department number 10, 20, 30, and we have the count, like 10 is appearing 3 times, 20 is appearing 7800 times, and 30 is appearing 300. Now if you look at the department number 20, the number of occurrence of 20 is predominant here. It's a large than the other two values. So you say that the data is skewed here because this is not uniform here. 7800 is way bigger than 3 or 300. So let's imagine a situation where we have two tables, employee and department. And department number 10, we have 1 million records, 20 has 20, 30 has 12. While in the department table, we have department number 10, 20 and 30. And the counts are like almost, it's very minimum 10, 1 and 1. Now, if you do a join a department number on the employee and department, so what will happen is here we will run into a situation where a single reducer or a few reducer will process the 1 million records. Now the other reducers will just process the 20 or 12 or 1 records, and they will run faster. They will complete their execution faster, but your job will be on hold because the reducer which is processing the 1 million records is going to take a lot of time. So there is uneven distribution of work for the reducers. So in such scenarios, what we do is we can use a skew join. Now how does this work? So what happens in skew join is basically you are joining the on skew column. Now the table that has the less skew, so here in this example we have the department table which has less value. Now the table that has the less skew, which is department table, now this department number will be stored in memory for that particular data only. So in your map join you store the entire data, but here what is happening is you just join the data, you just join the portion of the data. Like here the department number 10 is skewed, so we just store this department number 10 data in memory for that particular skew data, and it is only for this particular skew data. So this particular record will be stored in memory, and when the join happens, this memory will go and sit here, and the join will happen between this data which is skewed and this particular data. This means that the map side join occurs, but it is only occurring for a particular skew data. So it is only occurring for the skew data 1 million records. Other things are happening. All other data will follow the normal map reduce. So this is how a skew join works. So you just take the data which is skewed and then you bring it to the memory, and then the map side join happens only for that skewed data. The rest of the data, it basically follows the normal map reduce jobs. And there are certain properties that we have to set. So these are certain properties that we have to set for this skew join to take place. And again, as I mentioned, skew join, a sort merge join, or the bucket map join is something which is not very commonly used. Map side join is something which is commonly used. We have seen an example. You can try with the other joins as well, but you need to make sure that you set the right properties, and then you should have the data right, the bucketing, the number of buckets which are in multiples of each other. So you have to make sure that you have all this data set up before you can try the other joins, the bucket map joins or the sort merge joins or even the skew joins, right? So that's it for this session, and thank you so much for listening, and I'll see you guys in my next class. Hello and welcome to another session of Hive series. So in all our previous examples, what we have done is we have created a table, we have loaded the data into this table, we have created a partition table, we have loaded the data into this partitions table. Now what if we have the data in HDFS already, and we want to create a partition table on that data? Now we have not done this before, right? We have the data and we have given the location, but that was for the normal table, but we never created the partitions on the existing data. So let's try this. Let's try to have a existing data, and then let's create some partitions on it. So we already created some partition tables in our earlier classes. So what we'll do is let's make use of one of them. So I will check this tables here. I'll say show tables, and these are the different tables that we have created. So let me take any of the partition table. I'll take this partition table. So I will describe format it. I just want to check where the data is residing. So this is where the data is residing. So let me check here to verify if we have some data. Cool. So we have the data. So this is data related to the countries India and US. Now what I'm going to do is I already have this data here. So, and this is a partition data. So that is very important to note. So this is partition data. I have it already. Now I want to create a table on top of it. So what I will do is, let me go back here and I'm going to create an external table. Let me call it as partition table existing. So we have state, we have three columns, remember. So the first column was state, then we had capital, and what else we had language. Right. So we want to partition this table. So this is partition by country. Their normal row format delimiter. This is fields terminated by comma. We have a CSV file. It's a test file, so stored as test file, and the location, we have to give this location. Yeah, so this is the location, partition directory, so we'll use the same location. All right, so we have this table created, right? So now this table is basically looking at this data. This is this is the location, or this is the directory where this data is, and we have this data, we have just queried it. So here we have the data, we have two files. So so when you query this table, it should read the data from here, right? So let's try this. I will say select star from this partition table existing. Let's see if I have some data. Now it is saying zero data, but is it really zero data? Let's go and check here. So if I pick any one of this, let's say I pick up India. I have a file. So let me check this if we have any data. It should have data because the size is saying it has some data, but let us query it anyway. So we have the data. So why is that we are not able to retrieve the data? So what happens is, when you create a partition table, partitions are generated and they are stored in the meta store, the Hive meta store. So if you try to create a partition table on the existing data, these partitions are not automatically registered in the Hive meta store. So we need to recover these partitions. So in order to recover this partition, we use a command msck. So we say msck repair table, and then we have to give this table name where we have to add those partitions, right, or repair that partition. So if I enter this now, as you can see, it says repair added partition to the meta store partition table existing. So this is the country ID, country US. So these partitions are now added. So now if you do a select query, let me limit this to, let's say, 10. Now you have all the data present here, right? So this is an important feature. Sometimes you want to create a data partition table on existing data, and then when you query it, you will not see the result. So if you don't see the result, make sure that you first verify that the data is available, and then make sure that you repair this table. So when you do an MSK report, you will have these partitions registered in the Hive meta store, from where you can basically retrieve this data, right? So that's it. That's all I wanted to cover in this session, and I'll see you guys in my next class. Hello and welcome to another session of the Hive series. So here we will look at the some of the Hive performance tuning techniques. So we talked about partitions, how it is important. So when you create a partition on a particular column, make sure that we have the right amount of data in each of this partition. The data should be uniform, and it's something that you will be using in your where clause. If you create a partition and you're not going to use it in your queries, then there's no point of creating those partitions, right? Partitions will make sure that when you do a query, when you do a where clause, it will go and search only for that particular partition rather than scanning the entire data. Bucketing also does a similar concept, where you store the data, and then you segregate the data which is having a range into some buckets, and then when you query for the particular column, you will basically search, your query will basically search in one of the buckets rather than going through all the data. And again, make sure one for bucketing, make sure that you really need, you have a query where you are continuously looking out for the data on the column ID that you are going to bucket. Otherwise, this is again going to be costly, because each time you query it, when you insert the data into the buckets or something, for each bucket there will be a reducer job that gets invoked. So make sure that you use the buckets very appropriately. And again, map joins and skew joins, map joins where you have small data fed into the bigger tables on our data nodes. Skew joins, map joins occurs within the skew data. So these two joins are also very helpful in performance improvement. Then we have something called as vectorization. So basically, by default, Hive will process one row at a time. Now it may not be optimal, so if you want to enable if you enable vectorization, what will happen is Hive will process 1024 records at a time. So that's the improvement that it can make. Now the disadvantage is that it is going to occupy a lot of memory, so please use caution. If you have memory, if you can support that, then yes. If you enable vectorization, Hive is going to process 1024 records at a time. And to set up this property, you have to enable the Hive vectorization. You set hive.vectorized execution enable is true. When you set this, the vectorization will be enabled. And then you can do Hive parallel query execution. So what it means is, suppose you have queries that are independent of each other, then you can make them in parallel by enabling this Hive parallel execution. So if you look at this example, so here's a query that we have. So we have this inner queries, we have the outer queries. So if you look at stage 1 and stage 2, so these are basically inner queries. So by default, what will happen is, first stage 1 will execute, and then stage 2 will execute, and then finally stage 3, which is the entire query, will execute. But if you look closely, stage 1 and stage 2 are not dependent on each other, right? They're not passing any data between each other, so they can basically run independently. So if you enable this Hive parallel execution, both stage 1 and stage 2 will run in parallel, and then once they are complete, it will feed into the stage 3. So this way we can improve the performance. And to execute this or to enable this parallel execution, we have to set up this property Hive execute parallel equal to true. So if you enable this property, the independent queries will execute in parallel. So these are some of the basic performance tuning techniques that you can apply while fine tuning your Hive jobs. So I hope you like this, and I'll see you guys in the next class. Hello and welcome to another session of Hive series. Perhaps this is more of a revision for all of us, but this is one of the important interview questions that keeps people keep asking. So I thought like I'll cover this in a minute. So what is the basic difference between SQL and Hive? So Hive is schema on read while SQL is schema on write. So if you have a structure and you're trying to insert some data into the structure and the structure is not matching, then if you use a SQL, it will give you an error. But if you insert this using a Hive, it will not give you an error. So the schema evaluation will not happen when you are writing the data. The schema evaluation will happen when you're reading the data. So when you read the data, it will look at the schema, and according to the schema, it will fetch the value or the data for you. That is why Hive is schema on write, and it is used for analytical purpose while SQL is transactional. We covered this many times. Again, the repeated point, it's a data warehouse tool. SQL is basically is a database. Hive supports structured language, structured data, as well as the semi-structured data. So we Hive also supports semi-structured data like JSON, while SQL only supports structured data. So very short video. I just wanted to cover the basic difference between SQL and Hive just for the interview purpose. So I hope you guys like this, and I'll see you guys in the next class.